Okay, so we will start our chitin extraction from the mushroom. We will use 5 pack of 400 gram frozen mushroom here. So in total we have 5 times 400. We have 2 kilogram fresh mushroom to be extracted. Okay, now we will thaw this mushroom by running it with the tap water. We left this sample under water for about 5 minutes and then we rinse it again and we redo it for 2 times. Okay, after 5 minute thawing, we will rinse our mushroom. So make sure you put the strainer at the bottom so that you can catch the mushroom easily. And we will repeat the process again by running it with the tap water for another 5 minutes. Okay, sometimes you don't need to wait until 5 minute thawing because so long that your sample is already become fleshy like that, that's enough lah. Because the purpose of thawing it so that we can blend it easily later on. Okay, so we can rinse this, our second tap water immersion. For the third thawing, we will use a distilled water. So for this, we don't need to wait for 5 minutes, just enough. Because the purpose of distilled water here is just only to rinse our sample. Okay, so this is 2 kilogram of fresh mushroom that's already frozen and thawed. Now we are ready for blending this. Okay, so for blending, we will use this high speed kitchen blender. So first, we will take our sample and put into this blender, and then we will add some of the water before we can start blend this thing. So we fill up until 2 liters. One of the important things of using this high-speed blender is that you don't blend it for continuous period. For example, you need to stop for after 1 minute. You need to stop and then let it settle down, let it cool down a little bit, and then repeat that again another 1 minute like that. Because if not, this blender will sort of burn due to high speed and also high volume, cause this blender need to work more. See here, there are some some smoke there. When you use something that is high speed, you need to treat it slowly and maybe do it the experiment in batch, meaning that you blend for 1 minute and then stop and then repeat again, 1 minute, stop and then repeat like that. Okay, so you want the texture of your sample become more or less like this lah. Different mushroom will give your different texture, but roughly you don't want to see any particle or any sort of fleshy part seen lah. So typically what we did is that we do 3 times. So first one, second one, and then the third one. And the last 2 liters is typically for to rinsing of this blender. Okay, so this is our last batch of sample. After this, we will fill up this blender with 2 liter distilled water to rinse all the remaining residue here. So this is our 8 liter mushroom puri. So, but first thing before we do hot water extraction, we need to make sure this what we call the bottom of our pot is not wet. Okay, because as you can see here, there are some water, so we need to make sure it's not wet, and then we bring over there. And also it's important to make sure our hot plate also not wet. And then we put our overhead stirrer. Make sure we clamp it very tightly because this thing is quite heavy. And we also need to make sure that this is not center. Our pot here is not center, so we need to push a little bit so that our pot will receive even heating from this square hot plate here. Okay, so we need to check this carefully first. Okay, and then what we do is that we will start our overhead stirrer first. We will set our stirrer to 400 RPM. Okay, and then we will put in our temperature probe. Okay, and then we will start our hot plate. Let it for a while. And then we will set the temperature. Our set temperature for hot water extract is about 85 degrees Celsius. Okay, and then this will heat up, continue heat up until 85, and then after it reach 85, maybe because this quite a large volume, probably around 1 hour times, we will start our timer. So for hot water extraction, we just use 1 hour. So we will start the timer after it reaches 85. But here, if you set on the dot, 85 on the dot, when this temperature of this hot plate reach to 80 to 83, then it will have quite a hard time to reach 85 because you set it on the dot. So the best practice, not best practice, but the better way is to just ramp it up until 100 something, so that the heating will become continuous. But you need to make sure that when it reach 82 like that, 82, 83 like that, you need to turn down this knob until 85. So the purpose of we increase the ramp here is just to ensure that the heating will be continuous and hopefully it become much faster lah. But you need to make sure to check it time to time so that it doesn't exceed 85 here. Okay, so as for now, this our mushroom puri looks like under the agitation of overhead stirrer. Okay. Okay, so now it's already reached 85.7 Celsius now, and we need to turn down the temperature to 85 lah. So please make sure when you do this method to increase the ramp up and beyond the desired temperature, you must be aware lah when the temperature reach your desired temperature. So we reduce the temperature to 85 now. And it's already, we take around 1 hour for this volume of sample to reach 85 from ambient temperature, from room temperature. So now, because it's already 85, so we can start our timer. So hot water extraction is only 1 hour, so we start it. And then we just let it be for 1 hour. Okay, our hot water extraction already completed. It's already 1 hour at 85 degrees Celsius. And then let me see. So this we will then filter this hot water extract, and then we will try to screw press it to compact the sample. Okay, let's go. Our hot water extract already filter like this, so I think this is enough whiskers for us to proceed with our screw press over there to remove other excess water. So what we do now is that we close this filter close. Okay. Stop this first. Okay. Okay, and then using a zip tie, we will sort of like tie this tightly, so that our sample will not going out lah when we do screw press. So we will take this, and then we will put it inside this screw press. So as you can see, there are some of our filter close at the bottom here to prevent any rust, and then we will layer this on top with another filter close. Okay, we just put on top here. Okay. Okay. And then now we will press it using this. So make sure you have this, what we call the basin at the bottom, to capture this lah, to capture the filtrate later on. So we just screw it. So we make it like inclined, so we remove the water, the excess water there. So there are not much water because we already remove most of the water during our filtration process over there. So this is the purpose, just to compact it further only. So that's why you see there are less water. After we press, we take out our sample. So this is our press sample. This we can store it in a container here. Okay, so we just put it inside. Okay, so we extract our last bit of our hot water extract. So this hot water extract we will store it in the fridge, and we will take it out when we want to perform the alkali extraction. The reason why we can do that is because this is just a water, so there are no reaction happening in the fridge. So we will bring it out when we want to start our alkali extraction. Now we prepare our alkali solution, 1 molar alkali solution for 8 liters. So we need 40 times 8 is basically 320 gram of pellet, and then we dissolve it in the 8 liter of water lah. So we first measure the 320 gram of pellet first. We use our beaker there. Okay, so it's okay, it's plus minus 320, 330 is okay. And then we put our beaker to the side. And because we need to add alkali to the water, we prepare our water first. So this is 2 liters mark. So we prepare 2 liters of water, and then we put inside this, what we call, pot. And then only then we add the alkali to the water. The reason being is because the reaction between alkali and water is basically exothermic. It's release heat. So if we add water to the alkali, then there will be a risk of splashing, okay, splashing or boiling. So that's the best practice, is to add water first. So this is 2 liter water. And then we can add our alkali to this water. Okay, so then we can add water, another 2 liters water. Because it is just a small amount, then normally it's okay. Now we continue top up the water until everything is contain 8 liter of working volume. And then we stir this alkali so that all the pellet will be dissolved. So the agitation might take around like 2 to 5 minutes to make sure all the pellets to be dissolved. Okay, our pellets already fully dissolved. So now it's time to stop this agitator. And then we will take the entire pot and then we pour it into this our hot water extract. Okay. Now we can sort of like disperse some of the clump of hot water extract so that this clump will not interfere with our stirrer. Okay. Of course, we don't need to disperse it to break it until everything is homogeneous, because over time during 3 hours alkali extraction, this thing will be sort of like become slurry anyway. So the purpose of we breaking the clump here is just to ensure that our steering steering blade will not be hindered by this clumping lah. So just a few like that. Okay, I think that's enough. Okay, so we set the agitation to 400 RPM. So we see it's agitated first. So let it be. So while doing that, we will on our hot plate. And then we take our temperature probe so that it can regulate our temperature. So it will take some time for 25.8 Celsius to reach 65 degrees Celsius, which is our intended temperature for our alkali extraction step lah. So we will start our timer, the 3 hours timer for alkali deproteinization step only after the temperature of this thing, whatever inside this pot, reach 65. For time being, it might take like 30 minutes in order to reach to 65. So yeah, we wait. So now that's okay, it's already 65.1 Celsius, which is our intended temperature for alkali deproteinization step. So if you look here, we increase our set temperature to 80 degrees Celsius. The reason being is because if we set like 65, then it will take a long time for what we call for the actual temperature to reach 65, because it will on and off when it's nearing 65. But if you increase the temperature like this, it's important for you to check this so that when it reaches 65, then you reduce the temperature to desired temperature lah, which is 65. Okay, so the time needed for this from room temperature to reach 65 temperature for this size of solution is about 30 minutes. And then you can start your 3 hours timer here for this step. Let's see. Okay, after 3 hours elapsed, we can take our sample, our hot water extract sample. So this is the consistency of our sample after 3 hours. So we stop our agitator and we take the entire pot, because this is an alkali. So we make sure that we put our what we call our some tissue here to prevent the dripping. This 8 liter equivalent to 8 kilogram plus 1 kilogram of this container, so it's around 10 kilogram more or less. So for safety reason, better you use a trolley and to bring it to our filtration place. So now we put our sample into this filter close. And then we can just put on the trolley bag, and now we start our pump. Okay, so for this we need to sort of like agitate a little bit. It's important to keep stirring because the chitin that we extract will deposit on the top of the filter close, closing the pore. So by stirring it, we opening the pore so that more water can go down lah. More alkaline water can go down. And also you need to sort of like make like this, go to the end of the side, because if you can see here, there are some crevice there. So this cause the vacuum not perfect lah. So by sort of like leaning our spatula to the side like that, we will increase the sealing. Okay, the sealing of the vacuum. So now we will take the rest of our alkaline sample and put it on this thing. And please be aware that our working volume is 8 liter, and this pot will sort of like will contain, is a little bit bigger pot than this one, so it can contain about 20 liters of solution. So because we cannot really see whatever there because of the condensation happening there, we need to make sure that after we put all our sample, we need to remove the filtrate lah, because we don't want during the neutralization process later on, we add water, we fill up this thing, and then it will sort of like close the funnel. So be mindful on that. We already put about like 7 liters of our alkali solution, and the distance between our end of the funnel and the surface of the liquid still quite far. So I think if we put all 8 liters, still okay. For the first alkaline part, is take quite some time for it to get filtered. But later on during neutralization, it become easier and easier, because alkali here, the chitin in the alkali solution here tend to be sticky. Can you take some? You see this thing tend to be a little bit sticky now. I mean that it will attach to this what called close and sort of like close the pore. So that's why we need to do this thing. Okay, so you can see. Okay, after a while, this is our chitin texture after the first filtration of alkali step. So we remember we put 8 liter of our solution straight into this filter close, and then as you can see down there, where is the, difficult to see. Okay, as you can see down there, it's quite difficult because there are some condensation there. So the water level still not reach the tip of our puncture funnel. But to be safe, we will do this filtration 8 liter by 8 liter by 8 liter. Meaning that after we finish the first 8 liter, we will take out this thing. We will remove the whatever filtrate here into like a bucket there, and then we start anew. Okay, so we take this. We need to stop this thing first.
the filtration pump, and then because there are some vacuum here, so we need to remove the vacuum first by moving this thing. So you can see, so that's okay. So now we can take this and put on the what you call this container. So that's the reason why we make sure we have this, so that it will not tip off. The size must be correct lah. So if you look here, take down, so you can put somewhere here, maybe somewhere here or somewhere inside there. Okay, if you look here, this is the 8 liter of alkali filtrate. Okay, so this is our alkali extract. Okay, as you can see here, it's still well below half, but to be safe, we will remove this first and then let it empty, and then we start with the neutralization. For neutralization, we just add water here until it become neutral. Okay, so we remove first. We first need to check the vacuum first. Okay, let me open this thing. Okay, kita jangan guna tu. So make sure you wear the glove here because there are alkali there. Ada. Okay, so there are some vacuum still. So now we just transfer this again to the here. Okay, and then now we add water. We just add water. So that is 8 liter water. So we just put in a small amount first and repeat. So this basically what we call neutralization with excess water. And then we will stir this thing. So let the alkali extract become neutralized. So it might need like more than 20 liters of water. So we just use a tap water over there. After it's what you call the pH turn neutral, then we will wash the final 8 liter with the distilled water. So in order to check the what you call the pH of this extract, we will use this strip filter pH paper. So we just take one of it. So we just take one of it. Okay, and then we just put here. So the color is here. So we just put deep like that, and then we put on here, and we compare with this. So now it's still very alkaline. So it might need like how many times? It takes like 5-6 times of 8 liters water in order to turn this into neutral. If lifting the bucket is too heavy for you, you can use this chairbox, smaller container, to help you facilitate this neutralization process. So please be aware, every time you do this, you need to check the bottom whether the water surface reach the tip of the baca panel or not. Sometimes you need to wash the side of this filter paper so that all the extract can be neutralized. Because if not, the top one will remain unneutralized and the bottom one is neutralized. So we need to wash a little bit like that. And to make life easier, you can use this wash bottle. We just do like that. So yeah, so this still alkaline on this top one, so you can remove that thing like this. Okay, we done using 16 liter of water to neutralize this thing. So now this is the water on maybe 20 liter. Okay, so we want to check the pH of this. So what we do is that we use this pH strip, and then we just dip straight away like that, and then we see how it look. So now it's already
roughly 8, and yeah, so it's almost neutral lah. So we think that if we can finish this, then this thing is already done lah. It's already done. So it's already almost neutral now. Can I see? It's almost neutral now. So it takes about 16 liter there plus another 8 liter here. How much? Around 24 liters lah. Roughly around 20 liters for this batch is needed in order to turn it into neutral. Okay, so we will finish off this, and then we will rinse off with the distilled water. Okay, for the last rinse, we use water, the distilled water, to rinse the side of our filter close. Okay, so this is our final chitin extract sample that is obtained after we do the neutralization. So this is the consistency of our sample. It's quite thick, and to get until here, we first undergo the alkali deproteinization. So that is the filtrate of the alkali water, and then to neutralize this further, we add about 25 liters of tap water, followed by some at the end we rinse it with our distilled water just to wash it further. So at the end you get this. So all in all, it takes about 3 hours and 3.5 hours lah in order to finish this neutralization process. So now we will take this and then we will store it in our container. So we close this first, and then we take our sample. So we bring our chitin sample on the table, and then we will lay flat on this table for our easy transfer into our container here. So we just open like that. And then for this container, this is 1.5 liters container. We found this is enough in order to contain this thing. So we need to first spray the ethanol to this in order to remove or kill any residual bacteria that happen to exist within this container, because these samples we want to store it for quite time, maybe 3 to 6 months. Even though we put in the fridge, if we can reduce the number of microorganisms within this container, then it will prolong our sample longevity lah. So now we need to first, before we do anything, we transfer this thing, we need to measure the weight of this container. Okay, because why? Because once we got everything inside here, we will also measure the dry weight of this, and then because we know the total weight of our wet chitin, later on we can, by knowing the entire weight of the sample, we will know the dry weight, how much chitin solid that we have at the end. So for that, we need to measure the this container weight first. Okay, so now our container is around 100 gram. So now we will continue by transferring our chitin into this container. So in order to transfer this chitin, we use this scraper, but we need to make sure we ethanol this also first. And then we can scrap all our sample into this container. Okay, so now we will weight the entire sample, but we need to also remove all this thing using tissue. We can just remove it out lah.
Okay, so our total sample weight is 1.572. Let's say we minus this 0.1 kilogram before of the empty container. So our sample weight is about 1.4 kilogram. So that 1.4 kilogram is basically our wet sample. So in order to know the dry chitin total that is contained in the sample, we need to measure the dry weight first, and then we tally with our total weight here. Okay, so now we will find the dry weight for this sample. Okay, so now we want to find the dry weight for this sample. So we prepare our glass petri dish and also the spatula. The spatula need to be clean, so we spray the ethanol first. And also we have a small spatula to help us transferring our viscous sample. And then we will open this. And then we will take our long spatula and try to homogeneously make sure everything is homogeneous. Okay, make sure you label your petri dish first. Here we label A, B and C. And also here we put like a table here, A, B and C. And the first column is empty, represent the empty petri dish. And then when we add the sample, we put the value here. And then after drying, we put the value here and so on. So first we weight the petri dish. And then we add our sample. Remember, we already homogenized this sample. And then we note the weight and we jot down in our paper. Okay, once all three replicate fill up with the sample, we will take out our spatula. Okay, and then we will close this container. And then we will bring our sample. We will dry our sample at 120 Celsius for 1 hour and then see whether it's dry or not. If it's not yet dry, then we will continue another hours until the dry weight of all the sample become constant. Okay, while waiting our representative sample to be dried in the oven, so we will store our master stock in our fridge. This is our final chitin-glucan complex that we extract from this 2 kg of grey oyster mushroom. And the consistency of this stuff is like a gel. So you can see here, it's like a gel. And that is an indication of formation of nanofiber. Since our grey oyster mushroom here is mostly water, so the cell wall remains in its hydrated form. So the chitin is inside the cell wall, so meaning that the chitin fiber is not hornified. Hornification is a concept where the fiber bind to another fiber through the hydrogen bonding, and when that happens, it's hard to redisperse and it becomes rigid. So when you extract chitin from mushroom, naturally you will get the nanofiber in natural form lah. I mean, you can get this dispersed nanofiber form. And we store our chitin extract, chitin-glucan extract in never dry condition because it makes us easier and flexible to repurpose this stuff. We can redisperse it in water and make like paper, or we can just freeze dry it or dry it. So that's why we store it in never dry condition. If let's say we want to characterize this stuff, so we take a portion of it, we freeze dry it, and we subject it to analytical measurement. For example, spectroscopy using FTIR, crystallography using SRD, or density measurement, what else? Elemental analysis, thermal analysis, etc. If let's say we want to sort of like check its fiber morphology, then you can just take some and disperse it in the water and take a drop of it, put on the holder and chuck it into the electron microscope. If you want to check how strong is this stuff, then you can turn this into a paper and then subject it, break it under the force using the universal testing machine. So the final question is how much chitin inside this container. The concentration for this gel is around 4.6%, and this what we call, and we multiply it with the weight of this sample, we got 68 gram of chitin. So you start with the 2 kilogram of fresh oyster mushroom. At the end, you get 68 gram of chitin. In other words, there are 3.4% chitin from this 2 kilogram of fresh oyster mushroom. But the what we call this dry weight of chitin, this what we call the amount of the chitin can be varied batch by batch depending on the sample lah. Because if you look here, if you look at this mushroom, oyster mushroom have like a fan-like structure. You have a gill, and also you have like what we call, I don't know whether you can see or not, you also have the stem. So the stem is denser than the gill, but the what we call the weight for both can be the same because the gill can absorb more water. So if your sample have more gill, G-I-L-L, then there will be less chitin. Okay, but if your sample have more the stem here, which is more denser, then you have more what we call more chitin. So it depends batch by batch. Lastly, it's very important to label your chitin stock. Okay, you label with the concentration itself. So you know the concentration for this gel, and then you put the label chitin from mushroom, label with the concentration itself, so that you can easily repurpose it, you can redisperse it rather than you need to check the dry weight again. And also it's also important to label with the date of extraction. And typically we recommend to store this inside the fridge, and this, because it's never dry, it contains water, and when something have water, it will invite microorganism. Even though we put in the fridge, then there will be a risk of microorganism to grow inside this sample. So we recommend to use this chitin within 6 months, within 6 months of day of extraction. Of course, after that, still it's okay if you don't see any growth of mold. It's still okay to use it, but for us to maintain the reliability of your experiment, after 6 months, better you just extract new chitin from other batch of mushroom. And that is how we extract chitin-glucan complex from 2 kg of grey oyster mushroom. This method is versatile, meaning that you can use the same extraction procedure to any fungal sample, for example, mold, filamentous fungi, yeast, or mushroom. But note that for the yeast, the chitin amount will be lower, and certain fungi, for example, mucor have chitosan. They will yield chitosan. I mean, they have some chitin, but they yield mostly chitosan. And I think that's it for this how to extract chitin from mushroom. Bye.